All right, let's get right into it. We're going to be talking about how a huge industrial problem, waste wood, is being flipped on its head and turned into a super valuable resource. And it's all being done with some seriously impressive tech you can literally hold in your hand. This is the story of the 905 Wood Digital Refinery.
This sentence right here, man, it perfectly captures what's at stake. This isn't just a neat idea about recycling. For a lot of industries, this is about survival, especially with a crisis that's looming.
In that crisis, it has a deadline, 2034. That's the year Ontario's regional landfill capacity is projected to be totally, completely, 100% full. We're talking gone. And that's not some distant, far-off problem that is right around the corner.
Yeah, this is what the industry is calling the waste cliff. For years, the easy out was something called the Michigan lure. Just ship all the trash to the U.S. where it was cheap to dump. Well, that gate is slamming shut, thanks to trade issues and new tariffs. Throw in some hefty new local taxes on waste, and you can see the old way of doing things is just over.
So what do? The answer isn't a bigger hole in the ground. It's a much, much smarter system. And that is the whole idea behind the digital refinery. You stop treating this stuff like a liability you have to pay to get rid of, and you start seeing it as a resource you can actually profit from.
And this image really shows you how it works. Now, don't think of the digital refinery as a physical building with smokestacks. It's software. It's basically a go-between, a translator. It takes all the chaotic, messy, unpredictable waste from a job site and it cleans it up, digitally. So it's perfect for these new, very picky bioeconomy markets. And here's the core problem it's built to solve. It's called the quality gap. See, on one side, you have these big, messy piles of wood waste. But on the other, you have these high-tech reactors that need raw material that is almost perfectly pure. Just one piece of chemically treated wood can ruin a whole expensive batch. That gap is where all the value is lost, and the refinery's job is to build a bridge right across it.
Okay, so let's get into the nuts and bolts of how this actually works. We're not talking about a sterile lab here. We're talking about putting powerful AI to work on a muddy, loud, chaotic construction site. This is what's called the tactile edge.
So what's the engine driving this whole thing? Get this, it's a Google Pixel 10 Pro. That's it. Its Tensor G5 chip is so efficient it can run a really sophisticated AI model for a full 8-hour shift without overheating. Just think about that for a second. It turns a regular smartphone into an industrial-grade analysis tool that can make decisions all on its own, right there on site.
And this right here shows you exactly why the AI is so crucial. It's because of something called the visual fallacy. Just look at these two pieces of wood. To you and me, they look identical. But one is just clean, weathered pine. The other? It's loaded with invisible hazardous chemicals like arsenic. You absolutely cannot tell the difference just by looking, but the AI can. So how does the system deal with that kind of uncertainty? Well, it basically works on a guilty until proven innocent principle. If the AI knows the wood came from a high-risk source, like an old building being torn down, it doesn't just trust its own visual scan. It automatically flags that load and says, nope, we need a second opinion. It forces a mandatory scan with a specialized X-ray sensor to find out the chemical truth.
But this system does so much more than just sort wood. It creates what they call a truth layer. It's a legally defensible, unchangeable audit trail. It's so solid and so clear that it's designed to be fax-ready. You could literally send it to a government regulator or a border agent, and they'd have everything they need.
And this is what that truth layer looks like in practice. It's a 9-point certificate of origin that acts like a USMCA shield. It's basically a digital passport for every single load of wood. It's got everything from the GPS coordinates of where it was picked up to its precise chemical signature, all the way to a tamper-proof cryptographic hash that tracks it from the moment it's cut to its final destination. This is the document that gets you past border tariffs, no questions asked.
You know, and what happens if a load gets rejected? The system doesn't just say no, it delivers what's called explainable compliance. It uses its AI to automatically generate a rejection notice that literally quotes the specific section of the environmental law that was broken. There is zero ambiguity. It's like having a compliance lawyer built right into the app.
And you can see just how precise this is. The system knows the exact chemical limits set by Ontario regulations, so if that XRF scan detects arsenic above 2.5 milligrams per liter, boom, it's automatically flagged as hazardous waste. This isn't a judgment call, it's environmental policy enforced by code.
Now, to handle an audit that could happen years down the line, the system has this incredible feature called the time machine. It creates a static graph, which is basically a digital snapshot. It freezes the entire state of that decision, the exact AI model version, the sensor data, the legal rules in place at that exact moment. It allows the company to perfectly replay the moment of compliance for an auditor anytime. It's perfect recall.
Okay, so the tech is brilliant. It's clever, it's powerful, but does it make money? Let's connect all this amazing technology to the bottom line. How does this actually turn a penalty into a payday?
Well, first, it's about avoiding costs. In Ontario, there's a painful levy, a tax, that can hit you for $60 a ton for sending mixed waste to the landfill. By proving this wood is clean and diverting it, this system just completely erases that cost. Gone.
But here's where it gets really interesting. It's not just about saving money. It's about creating entirely new revenue. That verified clean wood can be converted into a stable type of charcoal called biochar. Doing that generates carbon dioxide removal certificates, or CORCs, which are currently selling for around $350 a ton. So you've just flipped a disposal cost into a huge revenue stream. And third, you have massive gains in operational efficiency. By sorting the wood at local spots and then shipping it in these giant mothership trailers, the system cuts down the number of truck trips by a factor of 4. That is a huge savings in fuel, time, and labor that competitors who are still dependent on landfills just can't touch.
Even the app's design is genius, built for this high-stakes world. So to finalize a shipment, a driver can't just absent-mindedly tap a button. No, they have to use this special hold-to-seal gesture. As they press the screen, the phone's motor vibrates harder and harder, creating physical resistance. It's called hostile friction, and it makes the driver physically feel the weight of the legally binding declaration they're making. It is so smart.
So if we sum this all up, what we're really seeing is the transformation of the urban forest. All that chaotic, unpredictable wood waste from our cities. This system uses data to turn it from a messy, expensive liability into a clean, precise, and incredibly valuable industrial resource for the new bioeconomy.
And that kind of leaves us with one last big question to think about. We've just seen how a regular smartphone can become a refinery for industrial wood. So, what other massive waste streams? Plastics, concrete, old textiles? What other industrial liabilities are just sitting out there, waiting for their own digital upgrade?